Alright. It depends on what way you connect your dots. If you just connect the next successive one, like as you go from left to right, then you're just probably going to look like Megan. But if you go in the order of the in-out table, it should look like the red ones. Okay? So here is our graph for the last one. So this graph, I would have something like that, then that, then that. All right. So what do you notice about the appearance of the graphs? They're sort of symmetrical. They're opposites, I've heard. What are they symmetrical of, though? If you look at that line, what are they sort of symmetrical of? If we would draw this line, y equals x, what does your graph do? Flips on it, so it reflects on y equals x. Let's see if it does on the other ones. We draw y equals x. Does it reflect on that? If we draw it here, does it reflect on that? If we do it on the first one, does it reflect on the red and blue one? Yeah. So, what we can state about the appearance of the graphs is it reflects about y equals x line, which is your diagonal line, the 45-degree angle line. Another thing that is true is that when you do compositions, so if you do fog, so if you take your inverse and plug it into your original equation and you get x, and you take your original equation and plug it into the inverse and you get x, that proves that they are inverses of one another. Proves that they are inverses of one another. Okay? So we've looked at a table. We've looked at the graph. Now let's do it algebraically. So let's come up with these equations that they did. These two things should also be one of your key things to know for next time. So, questions?
This stuff will be online?
Yes, sir. The PowerPoint will be online, and then the video will be online. I don't know if I'm going to be able to put your video online because it's not videoing very nice, but we will see. I will try to get it on there because you guys didn't get me on there the last time. So. All right. So to find inverses algebraically, you have 3 steps. The first step is to switch x and y. Kind of like our domain and our range switch. So that's why we're going to switch x and y. So if our original is y equals x plus 8, our first step is to switch. So you get x equals y plus 8. Your second step is to solve for y. This part of the notes is what you guys will be viewing from home eventually. Like I will do this ahead of time and you guys will be doing this and we will be working on your worksheet that's going to be homework in class rather than you doing it at home. So we're going to kind of try and flip it. It might not work because everybody doesn't have internet access, but all right, so we're going to solve for y. To solve for y, what do we do? subtract 8. And your last step is to denote your answer as y to the negative 1. So we are going to go x minus 8 equals y to the negative 1. So this is our inverse of that original equation that we started with. Inverses are denoted by negative 1. What other inverse can you think of that has a little negative 1 on it? On your calculator. The trig. Inverse sine, inverse cosine, inverse tangent. They are denoted by inverses because that little negative 1 there. Questions? Shall we try another one? Okay. So, on your own, do step 1. If this is our original of y equals 3x squared plus 5. Y equals 3x squared plus 5. Do your first step. All right, what is our step 1 on this one? Okay, if you switch x and y, what do you get for a equation? Okay, x equals 3y squared plus 5. Solve for y. Go. All right, to solve for y, what do you do first? How many of you divided by 3 first? Anybody square root first? If you square root first, you're taking the square root of this whole side. That's ugly. You don't want to do that. Since it has addition there and a multiplication, you don't want to do the square root. So you want to isolate your y squared first. So now what should you do? Not square root. Divide by 3. If you square root, then you're going to have the square root of 3 in your problem. Because you're doing the square root of this whole side, not just the y squared. So we're going to divide by 3 first. Now, and how do we denote our answer? Questions? If you took the square root in the very beginning, your answer is going to be jacked up. You can take it when you have the 3y squared, except for you need to leave the square root on the 3 if you do that. Okay. Cool? All right, let's try one more. We got y equals the square root of x plus 4. See what you come up with there. is what you want there. Yes, you can't just move that square root of 4 over. You gotta get rid of it. You're trying to do derivatives and all sorts of crazy stuff there. How do you get rid of the square root? That should be your first step. Okay, guys, I see lots of possibilities from different problems on here. So what we are going to do is switch x and y. So we got x equals the square root of y plus 4. Questions on that? Okay, from there, here's where some people are disagreeing. Some people have it as the square root of y plus 2. Some people subtracted 4, and so have x minus 4 equals y. Some people squared first. Can you take the square root of each individual part? Since there is an addition symbol there. No. If there was a multiplication symbol, then you could. So this is not good. Can you just move the 4 out from underneath there? No. So you need to square first. Then, what are you going to do? Subtract 4, Clayton says. Do we agree? And denote our inverse. So that is the correct answer. Questions? Your homework is a worksheet. And to know the 3 key things. What's true about our domain and range of our original and our inverse? Okay, original domain is the inverse of the range. Original range is the domain of the inverse. What is true? How do we prove that 2 equations are inverses of one another? Okay, fog equals x and goff equals x. What do we know about the graphs of inverses? They mirror or reflect on y equals x. How do we find inverses algebraically? Switch x and y and solve for y. Questions? Great job today.